In this module, we will be the first time that we're going to be talking about confidence intervals. Just as when the first time we learned hypothesis testing, you're going to see confidence intervals continue to appear throughout the course. So going through this one slowly and making sure we understand each piece will be essential in making the future modules easier on you. So let's first talk about what the idea of a confidence interval is, and we will do this by looking at an example. So in this example, we're looking at a random sample that was collected on 600 Boone County elementary school students, and from those we found that 29% of our sample is eligible for free or reduced lunch. Does that then mean that 29% of all Boone County elementary school students are eligible for free or reduced lunch? And let's explain our answer. So let's go through with what we know just from reading the example first. So I know I sampled 600 Boone County elementary school students. I definitely also know that that's not all of the students there. That's just our sample that we collected. It then also said that we found 29% of our sample is eligible for free or reduced lunch. So let's think about what this 29% is. Symbol-wise, this 29% should be our p hat. Now why it's a p hat instead of a p is because it's coming from just our sample of 600 students. So we know p hat is 29%. So then what they're asking us here is, from this information, would you feel comfortable and then actually saying, well then 29% of all of our students are eligible for free or reduced lunch. As soon as I say all, we're talking about the entire population, so now I'm referring to P. So do you think that this is a true statement? Well, just because we found something in the sample doesn't mean it's going to be true for all students. So my answer here then would actually be no, as this is just a sample. Right, because we only have 600 students that we looked at for that. It's not from all the students. So even though I don't think P is exactly 29%, one thing I hope is that if I take a sample and get this sample proportion, that it is close to what that true proportion of all students is. So that's sort of the idea of a confidence interval is going to allow us to do, is I get these results from this sample, how close do I really think that is to P? So we're going to be able to put a range of values on this P, or population proportion. So let's talk about things we already know. So we've already talked about the sampling distribution of our proportion. So what that means that we know that under certain conditions, that my p hat, my sample proportion, is approximately distributed normally with a mean of p and our standard deviation of the square root of p times 1 minus p over n. So again, just a reminder that mean of that p hat is our p, and that standard deviation of our p hat is that square root piece we see. So then we also know from the normal curve rule, or that empirical rule, that about 95% of our sample proportions should be within, well, let's look at that picture again. All right, so if I know it's normal, my conditions are met, I can draw this picture. We know that it's centered at whatever P is. And if I want to get that 95%, we're going to go out 2 standard deviations in either direction here. and get our 95%. So what I want to write down is what are these two endpoints. I'm just going to label as A and B. Well, let's think about mathematically, how do I get from P to this point A? Right, I'm going to go 2 standard deviations to the left. As soon as I'm going to the left, right, I'm subtracting off a standard deviation, I'm subtracting off another standard deviation. So we're going to subtract off 2 standard deviations from P. So mathematically, what does that look like? Well, so we're going to start at P, and I'm going to subtract off 2 standard deviations. Well, what's my standard deviation? We just said up here is that square root of P times 1 minus P over N. And then similarly, to get to B, instead of subtracting 2 standard deviations, we're adding 2 standard deviations. So that's just going to be then P plus 2 times our standard deviation. All right, so hopefully that part makes sense from what we've learned before. Now let's talk about the problems with this picture and this idea that we're discussing. And the first one is really the big one. So if I think about my scenario above in our example, the real big problem is I don't know what P is. Right up here I know what P hat is, but as we kind of discussed up here, we don't know that those are exactly the same thing. So if I don't know what P is, I really don't know what number goes in the middle. And as soon as I don't know what P is, I also don't know what this standard deviation is because it has P in it. Right, so we don't know that standard deviation. So what are we going to be able to do about that? Well, let's talk about a general picture to see if the idea could make sense here for us. So again, if I'm drawing that distribution, we know it's centered at P. And in reality, I could really put any percent I want in the middle. We happen to choose 95% because it's nice and easy because that's just 2 standard deviations out, but I could really put any percent I want in the middle here. So I'm just generically going to call this 1 minus alpha. And alpha, thinking about how we did with hypothesis testing, is generally a pretty small number like 0.05 or 0.01, for example. And so if I have 1 minus alpha in the middle, let's think through how much I have on either side. Well, let's do it for our first picture to see where that comes from. Right, so if there was 95% in the middle, there's 5% left over, and I have 2 different spots to put it in. So then I'm going to put 2.5% over here and 2.5% over here. How that works for our general picture is I'm going to have alpha left, and half of alpha is going to go on either of these sides. So this little piece will be whatever alpha over 2 is. This will be what alpha over 2 is. If I add up all of those numbers, I get 1 or 100%. So let's think about this interval that we have back here. Well, if I don't know what P is, I mean, I could plug in P hat for it, but again, we don't know that's actually the center of that value. But let's think about what it would mean if I created this interval with using P hat in place of P. What would that mean? Well, so what I know is that P hat's going to fall somewhere down here on this picture. Right, if you think about this picture in relation to our example, where would I put 29%? Well, I don't know if it's below or above P, so I can't really even place it on my picture, but it's going to fall somewhere along these lines. Looking at our general picture, it can fall in one of two places. I could first look at, and again, I'm going to kind of label these places, A and B. And so let's talk about if P hat falls between our A and B, and we construct our interval, using P hat as we discussed earlier, so kind of plugging in P hat where we had P before. So in other words, think about it this way. I'm going to think about where my P hat is on my picture, and then I would go out 2 standard deviations from it. So again, it's not going to be directly in the center. It could be like right here, and I'm going to go out 2 standard deviations on either side of it. Then this interval will contain P. Somewhere inside of it. So let's visually think about this here for a moment. So if my P hat happened to fall about right here, and I go 2 standard deviations above it, notice I just captured P. If my P hat happens to fall over here, and I go 2 standard deviations below it, it's going to contain P. So as long as P hat falls somewhere between A and B, when I construct that interval, P will be somewhere inside of it. Now if my P hat happened to be here, that interval is going to easily contain P. If I'm way out here, right, it's going to barely contain it, but it's going to be inside of that interval. But that's only true if P hat happens to fall between A and B. If instead P hat does not fall between A and B, and I construct my interval the same way, then this interval will not contain P. So then depending on how precise we want to be, or in a sense kind of what number we're willing to put in the middle, we can create a range of values, or what we call a confidence interval. So if we're thinking back to this general picture of what the 1 minus alpha means, 1 minus alpha is basically the probability that when we create our interval here, P will be inside of it. Right? So I want this probability, or that percentage, to be quite large, versus the alpha, that kind of leftover piece here, is the chance that our interval is not going to contain P. So I don't want this to happen very often, I want this to happen quite often. So in the next video, we're going to talk about how do I choose that percentage.